Okay, so in the last session, we were talking about deep learning architectures. So there's one deep learning architecture we need to study, and that is the transformers. So at first, transformers were used for natural language processing basically, and it was giving very good results, or the performance was very good as compared to previous methods. So it was actually giving much better, a lot better than the state of the art results at that time. So you found there were applications like machine translation, chat bots, etc., search engines, etc. Also, the transformers also were working well for sequence problems like parsing of sentences, um, and sentiment analysis and things of that sort. A translation where till now they were using things like RNN, recurrent neural networks, GRUs, and LSTM. You found that transformers were doing well, and then the transformer models kept on improving. We had things like BERT, GPT, GPT-2, chat GPT, all these type of things. So the transformers basically are based on what is called attention. So there's a paper which said attention is all you need, and that's the place where the idea actually came up from. So what you're doing in transformers basically is you're using what is called attention to keep track of the connection between words and between sentences which had come earlier, between chapters, books, etc. So the reason is because very large models were used and there was a lot of data being put into the system. So if this type of attention is available, it was found that the results were improving because of that. And because of the very good results that were coming, you could feed into the transformer very large data. For example, you can feed in maybe the poems of a very well-known poem, and you can ask the the system or the transformer to write poetry of the same type. Similarly, to writing stories, paintings, etc. For example, you can take a famous painter, say Van Gogh or some such, put all his paintings into the system and then ask it to produce a painting in the same style. So these type of things were possible. Also, not only in NLP, even in images, speech, okay, so that is videos. So in a lot of modes, transformers were actually doing well. So what we need to see is what you mean by the attention which is done over here, okay. So the attention allows the transformer model to attend on focus on different aspects of the input which is being given, or on the previous tokens like you would call them, okay. So this is your transformer model, which basically consists of an encoder and a decoder, and the input which we are putting into your encoder, an embedding is done and it is put into it and it is passed through the multi-headed attention. So this is the one which we need to see how this actually works. So here you have a lot of parallel heads, and each of these heads will attend on different aspects of the input data, and each of them will produce an attention score, and these attention scores are then merged and thus score is used. So what you find is it's built upon the concept of self-attention. So it attends to different parts of the same input sequence, okay, and it carries and it calculates a weight or a score for the different parts of the input which you are giving in, okay. So it applies it in parallel for different head, okay, and each head can work on a different aspect. So like one may focus on relationship between words, another might focus on the what is the context of the sentence, and the other one is what is the relationship between the nouns, okay. So these type of things. And then how does it work? The input sequence is split into multiple heads, and then parallel attention, that is attention scores are found, and then these are all combined together. So they are concatenated and then pass through a linear transformation to produce the final output. So this is how the multi-head attention basically works, okay. So we have an encoder, so and then we have a decoder, and at the end of the decoder you have the softmax and you get the output. So that's where the decision is basically taken over there. So what you do is when you are using an encoder, you can use stacked encoders. That is, you can have one encoder on top of another encoder, okay, like you can stack a number of layers which will make the transformer work better, okay. That is, the model can learn to extract and focus on different combinations of attention from its attention heads. So you have different models of deep learning which have come over the time, okay, and you first of all you had the transformer, OpenAI, and then you have what is called UNFIT and ELMO, and finally you have BERT. So ELMO is embeddings from language models, okay, which were first used, and then you have universal language model fine tuning. So you find that these are both based on using language models and finding embeddings using language models, and these whatever the advancements were done in these were all combined finally to form the BERT, okay. So using BERT, okay, this is one of the latest developments, that is the BERT, okay, and they describe it as a beginning of a new era in NLP basically, okay. And BERT with very little training towards the end can provide. So it's a pre-trained model. So pre-training can be carried out, and once pre-training is done, when you need to use it for a particular task, you don't need to do much training, okay, you just need to do a little bit of training, okay. So this was giving very good results basically, okay. So what happens is, first semi-supervised training is done on large amounts of text, for example some books maybe, or Wikipedia, or wherever data is available. So you use it to train the BERT model, okay. So by the end of the training process, BERT has language processing abilities capable of empowering many models, okay. We later need to build and train in a supervised way. So finally, when you have pre-trained BERT, okay, and you want to use it on a specific task, what you do is you use a classifier which you need to train, okay, pass it through BERT and then pass it through a classifier, and You train this classifier and you get the results out of it. So for example, maybe you're giving a tweets into it and you want to say whether it is spam or not spam, or you're giving in some emails and you want to check whether it is spam or not spam. So you're passing it through the BERT model and then through the classifier. You can use any classifier, you can use multi-layer perceptron, neural network, you can use other classifiers and do this. So what is it that BERT is built up on? So first is semi-supervised sequence learning, okay, which is what is done over here, and ELMO, like I said, OLMFIT, and OpenAI transformers, okay, and the transformer. So it uses all this information to get out what is called BERT, which gives very good results, okay. So like I said, you input everything into BERT and then through a classifier to get the output basically. So also maybe sentiment analysis, whatever you want to do, right? You can do that by using this. Okay, so there are two basic models in BERT. You have the BERT base, which consists of a smaller number of encoders, okay. So you have 12 encoders in the base version, and in the BERT large you have 24 encoders, and these have larger feed forward networks. Okay, this one has a larger feed forward network after that as the classifier. Okay, so the one of them uses 768 hidden units and the other one uses 1024 hidden units. So you have the encoders like this, and then you're going to pass it through the encoders of BERT, and then it goes through the you're only passing it through the encoder, so it goes from one encoder to the other. So you have stacked encoders, and then from there it is passed on to your classifier to give the final result basically. Okay. So it's found that you don't need to use much time to train the classifier. Okay, you're using a feed forward neural network plus softmax in this classifier. So whatever output you're getting from BERT, you're passing it into the classifier. Okay, so what I wanted to also cover is what is called the generative AI. So generative AI is something which is used a lot nowadays. So I just wanted to cover it, and of course we have already covered a part of generative deep learning. So this generative AI actually became better and performing well, with the advent of deep learning basically. So let's see what this generative AI is. So generative AI it's used to produce some type of novel content, okay, including either text or image, audio, video, or synthetic data, okay. So you want to produce new and novel content by identifying some patterns in the data which is already there, okay. So what you do is you have to train it on data sets which are available and then allow it to generate the content basically. So generative AI has been there for a long time. So they have been using some standard things like some old NLP techniques, etc., or keyword based NLP techniques, etc., right? But what was found is that when the GANs were discovered in 2014, okay, you found you were getting very authentic images. So you are using some real images and you are trying to generate new images, and you found that you were able to produce authentic images, videos, audios, etc. You could also give input of one kind and produce input of another kind. Okay, for example, you can give input with people with yellow hair, and you can get as output people with black hair, etc. Right? So you can actually change some things over there. And because of this, of course, there was a lot of new content which was being created. And one of the disadvantages was about the forged images, no, and it was difficult. So there were some cyber security attacks, etc., which were little difficult to handle. Okay, and the things which really helped in generative AI is the transformers. It was only when the transformers came and the performance started improving that you could say the generative AI actually picked up. And one reason for that was the large language models, where you could give in large amount of data basically. Okay. So what you are trying to do is you are trying to infer the probability distribution Pxy, okay, um, where x is the input and y is your output, okay, and you are trying to find Py basically, okay. Um, so you are able to produce new synthetic samples. Okay, so some of the examples is OpenAI's DALI, OpenAI's ChatGPT, okay, etc. So it was found that the models could emulate specific artists or even art movements. Okay, for I don't know anything about art movements, but maybe something like some modern art or some type of particular art. Okay, maybe if you ask it to produce images of that particular art or paintings, it can do that. Okay, so you found it could emulate specific authors or genres, uh, produce text ranging from technical to creative, or generate code in various programming languages, etc. So some of the interesting applications are like asking it to write a poem or a story, or an image generation model to create a painting or a photograph, etc. And the results you get is quite magical. It appears like it's been done by some human being basically. Okay, so these are all the building blocks. Okay, these are the things which are basically used over here. You have supervised and semi-supervised learning, deep learning, neural networks, GANs, transformers, large language models, NLP, GPT, etc. So all these are the building blocks, all these are the various concepts which are used in generative AI basically. So let us look at one or two examples. So this is created by ChatGPT. So so the input is create a single paragraph. So if we write a single paragraph, writing about what we want. Okay, so what this says is, in a post-apocalyptic world where cities lie in ruins and nature has started to reclaim its dominion, a lone house cat named Luna roams the desolate streets, etc. Right? So this has to be so what was the input given for this? Create a single paragraph writing about a house cat living in the post-apocalyptic world. So this is what was the output which was created for this. Another in images is using DALI, an image generation model. So in response to generate an image of a bustling Renaissance era city populated by anthropomorphic animals. This is the picture which was produced basically. So these are examples of how generative AI has been basically used. So we can say generative AI is a subset of deep learning. It's also a part of supervised learning, and this whole thing is a part of machine learning and artificial intelligence basically. Okay. So first GANs. Okay, so we have seen what GANs are, which use adversarial training. Okay, so you are going to have a discriminator and a generator, and they are going to be trained against each other. Okay, so we will not go into what is being done, all we can say is we are doing this process and both the generator and the discriminator will improve, and once it improves the discriminator is removed and the generator is used to generate examples. Okay, so this is your discriminator where it's going to discriminate between real and fake, and that is used to train the discriminator as well as the generator basically. So let us look at some of the applications of GANs which are very much come in the generative AI, right? Only these bottom ones are not so relevant, you can say. Generation of high quality images, image in painting. Okay, so that is if there is some part of the painting which is missing. For example, if it's an old painting where some of the paint has come off or it's got smudged in places, etc. Super resolution, where you take images which are not of super resolution and you produce super resolution images. Video prediction and generation, facial attribute manipulation, anime character generation, image to image translation. So you take image of one type and you produce image of another type, text to image translation, face aging, image blending, etc. So let us see some examples. So this is the ground truth and this is your adversarial example. So we can see that it's actually very close to each other. So here also you can see one of them is computer generated, the other one is real. So this is another example. So you could also use GANs to use some type of user edits. So here you are saying produce the image with grass, right? So it is putting that. Then here you are saying produce the image with the mountains. So the mountains are added to it, and then produce with the sky, blue sky. So blue sky can be added to it. So this way you can not only take the original images, you can change the original images in whatever way that you basically want. Okay. So these are all generated images. You can see this rightmost column is the actual digit. So these are the generated digits which we got. Here also we have the rightmost column showing the actual facial image, and these are all the generated images of the various types. So these are generated bedroom images, right? We have a bedroom data set which I had showed you earlier, right? So it's if you use what is called DC GAN, okay, so using that, these are the generated bedroom images. And here actually what you are going to do is you are performing what is called the vector arithmetic. Okay, so these are the original images that we have. So we are saying that you minus the glasses from that, right? And then change it from a man into a woman, okay? And then you get the woman with glasses basically. So what you are doing is you are starting with one type of image and you are ending up with another type of image. So here we are able to change the pose, elevation, etc. So you can see that whatever faces you are starting off with, you are changing the pose in this. Here you are changing the elevation, and here you are changing the lighting. So you will find that you have the light, the ones with more lighting and the ones with less lighting, and then wider or narrower. Okay, so we can see the face is becoming wider or narrower. So all these things can be carried out on the faces that you are trying to generate. Similarly, here is the chairs. So you find here you have rotation of chairs. Okay, so you can if you have a chair at a particular angle, you can change it to a chair in a different angle, right? And here the width actually you can see is varying. So this has small width and this has large width. Okay. So These are all produced by this is produced by what is called the InfoGAN, Information Maximization GANs basically. So here you have what is called the style transfer which is taking place. So you have you have the zebra and the horse, and you're saying that you want to change the style of the zebra and the horse. So what you find here is the you find that the zebra is converted into the horse, and here a horse is converted into a zebra basically. So here we have this is what is called the cycle GAN, which, well, you learn image to image translation. So you have image of one type and you are producing image of another type. So you have a Monet here and you are converting that into a type of photograph, and the photograph is being converted into a Monet. Monet is a painter basically. And here the same thing what we saw, the zebra is converted to horse and the horse is converted to zebra. Here a summer picture is converted to a winter, and a winter picture is converted to a summer picture. So these are all the image to image translations. And then we have conditional GANs. We saw how we can use conditional GANs, and we use conditional GANs to generate images of different classes, or with some additional information which you are giving into the GAN. So we find that using conditional GANs, here there are 9 classes, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and images are generated of all these different classes. And here again image to image translation. So here you have some type of a segmentation thing which is converted to a street scene. This is a aerial map which is converted to a map, and here labels to facade. Here this is a day picture and it is converted into a night picture. Here black and white is converted to color. Edges, a sketch you can say of the is converted into an actual output or to a photo. So these are all done with the conditional GANs. And here this is the text to image synthesis. So the additional information you are giving into the conditional GAN is the text. Okay, this text you are giving in over there, and it uses this text so that it influences the output which you are going to get. So this says something like, the flower has petals that are bright pinkish purple with white stigma, right? And these are the flowers that are produced. And here you have this magnificent fellow is almost all black with a red crest and white cheek patch. So it makes use of this to generate the appropriate images basically. And here you have the face aging. So you have, this is the original, and you'll know at what age the original is. And what you are going to do is the reconstruction of the original and reconstruction optimization. So that is carried out, and then at any particular age you can get the image of the person, how the image is going, how the person is going to look at that particular age. So face aging is done. So the additional information you are giving is the age of the person, and you are using that age to change the image basically. And here you use what is called coupled GANs. So you have two sets of pictures over here. We have the ones with yellow hair and the ones with the darker hair. Okay, so you are converting the blonde into the darker hair, and the facial expression from smiling it's being changed, and this one from glasses without glasses, etc. So these are what are done using coupled GANs. and these are anime characters which are generated, okay, and this is done using what is called the cartoon GAN. So we have seen that there are many types of GANs, and each type of GAN is used for a particular application basically. Okay, so we saw transformers, so let us see what all transformers can do, right? So what is the generative AI task using transformers? Of course, we do have image translation, etc., but things like text summarization, machine translation, question answering, text generation, all these things are done, okay. And in text generation you can do things like content creation, generating articles, blog posts or social media content, text summarization, machine translation, dialogue systems, creative writing, assisting in the development of stories, poems or scripts by generating ideas, characters or plot lines. So text generation actually helps in a lot of ways. That's quite obvious, right? So we can say that generative AI started only because of the transformers, because of the very good performance that you were getting from the transformers basically, okay. So what are the some AI tools that we have? You have text generation tools like GPT, Jasper, AI Write, etc. Image generation tools like DALL-E, Midjourney, Stable Diffusion, etc. Music generation tools, code generation tools, voice synthesis tools, etc. Okay, AI chip design tool. So these are all different tools which are available for generative AI. Okay, and this gives actually a full set of what are all the models that are available. Okay, so we have GPT-4, Llama 2, DALL-E, Music LM, okay, for speech generation system, which is used for AI music generation, etc. So basically generative AI, you could say applications can be divided in this way. You can have generative AI in text, code, okay, programming code, images, speech, video and 3D models, right. So these are all the applications that you could have. So if you take image, you can have design, media, advertising, consumer social, image generation, etc. Okay, so all these are the various applications which you can use. So this gives you a bird's eye view of what are the generative AI application. You can have in art and design, music composition, content creation, fashion and products, financial forecasting, etc. Okay, so all these are the various, and this gives a snapshot of the AI tools which are available. So we have seen things like Chat GPT, DALL-E, right, and then many others, right. So voice generation, design generation, video generation, music generation. So we have a whole lot of tools, generative AI tools basically. And these are some large language models which are there. BERT is one of them, GPT-2, GPT-3, etc. Right? Quite a lot of them, OPT, GPT-4, right? Of course, the ethical and bias has to be taken into consideration. So if there is a bias in the data which is being fed into the generative AI system, then there will be a bias in what is generated also, right? So that is the what we have to see. Also, if generative AI produces something, just like you have ethics in AI, you also have ethics over here, right? So they may infringe copyrights, there may be a problem with the original source from which is drawn, who will take responsibility for all these things, etc. So these type of things will always come in and you have to see. And this bias in generative AI is something which can be dealt with only by seeing that the data which is generated to go into generative AI is genuine, right? And there is no bias in that. Okay, there are still some challenges, but you can say that it's coming up quite well. Okay, it can provide inaccurate and misleading information. It can promote new kinds of plagiarism. Okay, it makes it easier to generate fake news, and you can claim the fake images as real photographs, etc. It would impersonate people, etc. So these are some problems you can have. Okay, but it's likely to come up, and the whole lot of applications are going to come. Okay, let's not go into all these applications, but there are a whole lot of applications where the generative AI can be used, and you could use it for good things, for example, to write code, design new drugs, develop new products, redesign business processes, transform supply chains, etc., which are actually useful things. So it could be used also, it can create mischief by using by creating fake photographs, etc., but it can also be used for useful things. So we'll stop this session at this point.